Bonjour à tous, welcome everyone, and bienvenue à Montréal si vous venez de plus loin. It's great to have all of you here, and today I will talk about large language models because it's hard to have a discussion about AI these days without talking about them, and I'll say a few words about some of the ethical concerns that I and others have been discussing as well. So let's start with what is this? So large language models are large neural nets. I mean, language models are things that existed before neural nets, but in 2000, my group introduced architectures of neural nets to do language modeling, which I'll explain. And the ones that really attract the attention here are the large language models that are used, have been tuned to do dialogue. In other words, that you can ask questions, get answers, and continue the discussion. And the reason they attracted so much attention is because they master language in a way that is comparable or better than most humans. In fact, you could argue that they passed the Turing tests, which is exactly this. If I interact with a machine, or if I interact through a keyboard with an entity, which could be a machine or a human, am I able to make the difference through the dialogue that, this is a machine or this is a human? And yeah, they're so good that essentially we are at that stage. So how are they being built? I'm gonna talk a bit about that. So there are two main training phases, and this is an idea that also came from our work in Montreal, but also with parallel work with Jeff Hinton and Yann Lequin in the first decade of the 2000s, which is we pre-train these systems and we train them with it using an objective which isn't the one that we're gonna care about at the end. And that pre-training is what we call unsupervised. So they're just trying to capture something about the distribution. In the case of language models, they're going to be trained to, for example, predict a missing word in a sentence given the words around, things like that. Essentially, they're trying to capture the coherence between words in an ordered sequence. And what's special about the modern large language models is that they're trained on huge quantities of data, like a significant fraction of everything that is available on the internet. And then in the second phase, training is going to continue, but with a different objective that's more tailored to what we care about. So that's called fine tuning. And in the case of ChatGPT and others like this, the form of fine tuning that really works for dialogue is that we're going to use the feedback of humans using the system in various ways in order to tune some of the parameters so that it will behave more like not just predict the words in a sequence that look like text, but actually answer questions and like be polite and please the humans that they're giving feedback. So that's the high level idea. Okay, so let's dig a little bit more. So these neural nets that I talked about that we presented at NeurIPS in 2000, that's 23 years ago. How do they work? The simple version is that they take a sequence of words which comes from a corpus and they try to predict the next one. So what it really means is they output a probability for each of the possible words in the vocabulary given all the previous ones. So the neural net is seeing through some neural architecture all the previous words, and it has a huge output, which was the main challenge in those days, with 1 unit per word in the vocabulary. And these outputs sum to 1 so that they can be interpreted as a distribution. And there's a way to train that to maximize the probability of generating the right word. There's no right word in language, but the word that actually happened in this context. So it's not like classification problems where there is a right answer. It's more like there are many possible answers and some are more likely than others. And so you're really learning about a probability distribution. Right? So in the figure you see, given if to train, we have the sentence, my name is Sylvain. I guess Sylvain did this figure. You would start by giving it as input just something that says it's the beginning of the sentence, and then and then you ask it to predict name, and then you give it my name, and you ask it to predict is, and so on. Okay. Now, something that we did shortly after, and that is used in many of these large language models, is that when we train, we don't only train to predict the next word given the previous ones, but we also train in a way that we can look at contexts after as well as before. And so to do that, we will mask some of the words. Like we will replace the identity of the word by like a special token that says, we don't know what the word is at this position. And then in the output, we'll penalize the network for making the wrong predictions at those locations. And there's a lot of interesting math behind this. We can show that this procedure actually, if you train long enough and you have a big enough network, captures the underlying distribution of the sequences of words. So this is something called denoising. In those days, we talked about denoising autoencoders, but the same trick is used when we train some of the large language models. Okay, so we're jumping 1 decade at a time here. So now we're like 3 or 4 years ago, and people start experimenting with these neural nets, larger and larger, with larger and larger data sets. And what they find is that they keep getting better as you scale the amount of compute, the amount of data, and the number of parameters. So there was a belief in the past that the performance of these systems would saturate as we make them bigger and we train them longer and we add more data. But no, I mean, there is an exponential effect where each improvement gets smaller and smaller, but it keeps getting better on a log scale. All right, so just a few months ago, I would have said building these kinds of large language models is something that requires huge amounts of capital that just a handful of companies in the world could do. But the game changed recently when one of the large language models trained by Meta, Facebook, was leaked in the open source community. And people found ways to do this second phase of fine-tuning in a way that was computationally cheap, to the point where you can now do it on a beefy laptop. And it's not going to take months of training. I mean, what takes months of training, we could take a lot of compute, is this pre-training phase on huge corpus. But the fine-tuning that makes these things specialized to a particular task, that can be done pretty quickly. And one of the methods that really makes a difference is this low-ranked LoRa method, actually invented by somebody who's here at Milan, and is one of my students, but he did it before he came here, Edward Hu. So yeah, people inside the big companies that now think that the moat that they thought they had to protect sort of their market with these large language models is disappeared. And people in the open science community are also starting to bring about the resources, capital, and so on to train legal large language models, because the current ones are all illegal in some way. So large language models are here and spreading like viruses. So why do I say this? It could be used for good, and there's a huge, set of potential applications and markets that people are exploring for these systems because they're so competent. And they also make mistakes. They correspond to doing something like our intuitive abilities, but they don't reason very well. And so they will not be always coherent, and there are all sorts of issues like this. But many people are now concerned that in the wrong hands, these could be used in ways that could be really dangerous for society, in particular to destabilize democracies. And you probably know that we already are in the kind of difficult situation with political polarization and disinformation that's been, say, accelerated by social media, but now there's a concern that these tools could be used to make the situation even worse. So right now, for example, there's lots of disinformation coming from human beings, trolls, but the people who do that, they're limited by the number of hands that they could put on this. But if it's AI systems doing this, it could be scaled up and really dangerous. So one of the things that we're pushing very strongly here at Mila is policies, regulation. How do we organize society so that we protect what is good and hopefully also benefit from the good sides of technology? And I've been a strong advocate of accelerating the putting in place regulation here in Canada, but around the world. And there are simple things we can do to reduce the kind of risks that I've talked about. For example, when you interact with an account, somebody in social media, it should be displayed. Is that a human or a machine? Or it might even be banned that it would be a machine. It would have to be a human. The accounts that are used should be validated to make sure that somebody who's shown their identity is a human or a corporation that we can trace back, just like we do for bank accounts. It's not like something that we don't know how to do. So the bottom line here is, in order to move forward in a safe way for society, we're going to need to raise our level of individual and collective ethics and awareness of the good sides and the bad sides. And it's not going to be easy to do that, but I think we have to. All right, I think I'll stop here because time is over. And thank you.
So thanks, Yoshua, for trying to summarize this in a quick 10 minutes. I think there's more to be discussed. So with this being said, I'd like to invite Simon Lacoste-Julien to join you on stage. Simon is an associate scientific director and core Mila member here at Mila. He's also an associate professor and a Canada CFAR AI chair at University of Montreal. And he leads the Samson Advanced Institute of Technology AI Lab located here at Mila. So without further ado, I'll leave it up to both of you to start off the discussion.
All right, thanks, Yoshua, to set the stage for interesting future months in AI. I think today you already gathered a few of the current interesting thoughts. So by the way, if people want to ask questions at any time, you can already show up at the mic. What I'll do basically is start asking questions, Yoshua, but if you want to already ask questions, please walk up and I'll call on you. But so perhaps for the first question, like if we focus a bit more on the science here behind large language models. So what do you think are the capabilities of large language models that didn't exist last year that they are displaying now? And do you think we are kind of an inflection point regarding that?
We are definitely at an inflection point, but it's complicated. So if you look at the science behind the current large language models, there isn't much that is really new that we couldn't guess like 3 years ago. There are little things, and putting the, reinforcement learning on top of language models. People have been doing this for many years. The particular way that it was engineered by OpenAI clearly, matters. That they've succeeded to make this thing work. But the neural net architectures and ways that are trained, they're not really new. The thing that was really new, there are two things that were really new. One, scaling it up, and it makes not just a quantitative difference like in the curves that I showed, but try it out. You'll see, like, it's nothing like this existed as far as I know until second point, they made it public. So the other big thing that makes it an inflection point is that they made it accessible to hundreds of millions of people. I think I read 200 million this month or something. And that, well, so first of all, like people like me who are not in these large industries didn't know that we had reached that capacity. Also, having the dialogue system, not just a language model, makes a difference, because it's not just completing your sentences, it's also actually like seeking knowledge and trying to use it to answer the questions. I mean, seeking knowledge, not in the way that we typically do, but more like our intuition. So if you kind of vaguely know something and somebody asks you a question, that's the way they answer. They don't like try to very carefully bring up the pieces of knowledge together in a coherent way. But a lot of what we do in our daily life is just based on like this same kind of process. Many of us, and most of the time, don't reason very much. So the kinds of mistakes they do also look like people are just, speaking without thinking, bullshitting or whatever. So people call it hallucinations. Anyway, so technically, there is no revolution, but there is, in a way, a social revolution and an engineering revolution.
Yeah, it's true that the fact that it's publicly available and so many people are using it, particularly my parents, so that means something is happening. Is that a question? Go ahead.
Thank you very much for your presence and your participation. I saw a podcast from Jeff Hinton with Peter Abil. And one of the things that Jeff Hinton said that was very impressive for me was that backpropagation is actually more powerful than the learning algorithm we have in our mind. And it could lead to superhuman intelligence, but he's not really interested in that. He's more interested in the human intelligence. And I think you have a research program in neuro AI and also like the global world space that you are looking at. I'm wondering, my question is, what are the synergies between these two threads of understanding the human brain and scaling transformers, scaling backpropagation to have superhuman intelligence?
Yeah, let me first try to kind of comment on Jeff's idea that it actually is probably the thing that made him switch from, oh, let's not worry about it, to it is a big issue. In addition to ChatGPT, right? So human brains and biological brains are limited in ways that computer programs and computers are not limited, because they use analog computation, which means, and also we have a very small output channel. Like we can't output a video. We can't, and even worse than that, we can't output the weights in our brain, like the parameters that make us intelligent. We can't communicate that, but computers can, right? We do that all the time. In fact, that's the way we train them today. We have thousands of GPUs or machines that are talking to each other, and it works because we're using digital technology. Means we can copy perfectly the information. And of course, the bandwidth of communication between those machines is high enough. And so and they can also have access to storage, like read the whole internet in a few days. And a human, would take 10,000 lives just reading to get that information in. So that's why he's concerned. Now, regarding the synergy, I've been, working for at least the last 6 years on what is missing technically. So, going back to Simon's question about the science behind the current state of the art in machine learning and deep learning, LLMs. What I think is missing, so what I've been pursuing, is something that humans have that the current AI systems don't have. And roughly it corresponds to our high-level conscious processing. So everything that goes through this little bottleneck called working memory, which contains your thoughts and the things you can verbalize. There is no such thing in the current state of the art. And I've been like hypothesizing and writing, papers and doing experiments to try to understand what advantages this bottleneck gives. And yeah, I don't have time to give a talk on this right now, but it would help to make systems that could generalize from much less data, that would be able to reason in ways that are more like the way we reason, to understand causality, for example, and other goodies like this.
All right, we can go to your question. Present yourself as well when you ask the question.
Sylvain Laroche from IRAP at NRC. At the beginning of OpenAI, it was a non-profit organization, and their goal was to democratize AI. Since it became profitable with a lot of billions from Microsoft, what do you think about the fact that they switched to open source, non-profitable to profitable? At the end of the day, that changed the big picture of what's going on, even if they put what they do in the public. I'd like to, if you can talk a bit about that.
Yeah, it's a tricky question. So if you had asked me 6 months ago, I would have said, okay, it's just like commercial kind of incentives. And I'm sure there is that. Once you have something that you think is very valuable, there's a temptation to keep it secret so that you can be the sole beneficiary. And that's how our economic system works. So we've been in a phase for about 10 years now where large companies, IT companies, have been doing machine learning research with machine learning research groups with real researchers who publish regularly everything they do. And why did that happen? It's not completely clear, but I think one of the reasons is that they were trying to attract the best minds, and the best minds want to be free. They want to share their ideas with the whole world. But now, I hope not, but maybe we're like in a phase transition. We're seeing some signs of that, where the commercial value of AI, especially these large systems, is putting a huge pressure to do the opposite, to do these things in secret. Now, if you ask the OpenAI leadership, they will also say that they're doing it for safety reasons. They don't want their system to fall in the wrong hands. And I think that's an argument that could be valid, but I'm sure the commercial motivation was there as well.
As you said, it's a very tricky question.
So I think regarding the openness of research that these large companies did, my one guess also is that it was in their benefit in the long term, because they knew that this kind of technology, even though some other companies could also use it, it's so core to their business that the benefits. And indeed, I think it has accelerated a lot the progress.
Yes.
And now I guess they're
science progresses exponentially because we can build on each other's work. And the more we publish our code, we explain our ideas, the faster, like the exponent in the exponential changes. It's like changing the time scale. If it takes 1 minute for information to go from one place to another because we share it on archive, versus it takes 2 years because somebody leaves the company and then kind of leaks that information, that's how the exponent changes.
All right, I guess we have lots of questions now.
Thanks. Yoshua, you mentioned that basically the big tech companies are losing their moat because everyone can take a pre-trained LLM and fine-tune it to any specific task, okay? But we're still relying on these LLMs.
Yes.
That are black boxes, trained on and seen. And
well, they're black boxes, not from the point of view of like understanding how to write the code and make them work. They're black boxes from the point of view of understanding why they answer in particular ways.
True, and also because of the data set that were used for pre-training.
Yeah,
that
we
are
don't know what the
potentially
data sets are right
problematic,
now
yeah.
for these guys.
Yeah. So do you see a pathway to scaling down instead of scaling up in order to get?
Absolutely. It's happening already.
Okay.
So first of all, for example, Meta released multiple versions of their LLM called Llama, and some were like very big and some were smaller. And I don't remember the detail, but the one that was leaked was not the biggest one.
Yeah.
And you can do a lot even with these smaller ones. And then people, I mean, I've been actually part of this many years ago. People have been working on how we can take large neural nets and make them computationally more efficient by discretizing the weight. So once they're trained, especially, it's easy. Instead of having 32 bits or even worse, 64 bits precision, you can go down to just a few bits.
Yeah.
And that, you know, with the right engineering, you can make that thing consume much less memory, which is a big bottleneck for GPUs, and run faster.
So do you think companies can then train their own language model instead of relying on some APIs?
They can, I mean,
If we go down.
Yeah,
I mean,
The smaller companies can clearly do fine tuning. And what's interesting with the LoRa method that I mentioned is that you don't need to fine tune everything. Otherwise, it would be as expensive. You just need to fine tune a few of the parameters and in a particular way that will actually change the behavior quite a bit without changing. So one way to think about it is that the weights of the neural net contain a lot of knowledge implicitly. And then what you're doing is just changing the way it interfaces with the world to answer specific kinds of questions in a particular way.
But we'll never train from scratch if the models are smaller.
No, nobody has the means to train from scratch, except if you're one of these big guys and you want to spend
Millions of
more than millions. Yeah.
Thanks.
Yeah.
But right now, is there any legally usable large language model that you can fine tune for a company to use without exposing themselves to like liabilities and legal risks?
I don't know. I know that people are building it. It's coming.
So open what you said? Open Assistant. Okay, so you can Google Open Assistant. Okay, so
Yeah, but it also depends on the size of these systems.
But then there's also
but it's coming. Like organizations are more and more, now that we know what we can do with these systems, it's going to happen more and more.
Because there's also a question of you know, the legality of the data sets used to train these in an open source community, right? And for example, oh yeah, I know. I'm just saying for, I mean, I think these big companies have the means to try to do a lot of litigation. I'm talking for, let's say you're a startup. Do you want to subject yourself to this risk?
I don't think that the lawsuits are going to be against the startups because there's not enough money there. No, I mean, individually, the startups are too small to be worthwhile, these lawsuits. So they're going to go after the big guys.
Next question.
Thank you. David from Move AI, data scientist. My question is related with prompt engineering.
Yes.
Prompt engineering is becoming, it's very interesting because as you say, there is no revolution itself regarding the technology, but it's a social revolution. And I have been part of proof of concepts, and even in my family with my parents, they interact with the machines as programmers. We don't have any knowledge of programming.
Exactly.
And that's very interesting because in some way, I believe
or
that,
dangerous.
yes, they think this revolution is for real democratize the access of AI to anyone. And I would like to see your opinion or vision about how it will be the future of, well, in general, what can be the most, I don't know, what is the scope of this? How we will change the way that we are interacting with machines? Because, for example, I don't need to code a lot of things. Now I can just for a little prompts have a better answer, like it save codes, it changes everything.
I mean, you can also generate code, you know? And now the code generation isn't quite as good as humans because it's missing the sort of system to reasoning and so on. But it's already being used to really speed up the programming task of humans. And If there's a human, by the way, that's another thing that's important to say about the use of these systems. Because they make these mistakes once in a while, incoherent outputs and stuff. Right now, the best usage is either where we don't care if once in a while they make these mistakes, like there's no big consequence, or there's a human that's going to, look at the answer and use it for something. So if you're only asking for suggestions for some, helping you in your work, and you are able to filter, what makes sense and what doesn't, then it's fine. If it's for fun, chatting, it's fine as well. But right now, it's tricky to use these systems where the wrong answers could have very, bad consequences for people or for society.
And regarding the scope of the access of anyone to AI, because I believe that.
What do you mean by the scope?
The scope is anyone right now can program. We don't have any knowledge of program. You can easily give instructions to a machine, follow your instructions. That's impressive.
That's that we're going towards more and more of that, which could be hugely beneficial for it's like right now, for example, there's a lot of information on the internet, and you could use search engines to get some of that, but maybe the answers you get are in a language that is difficult to understand and so on. And even like typing the right queries and searching through the answers may be difficult. But if we have AI assistants that can synthesize that knowledge, that can help us through a dialogue to make sense of what we're looking for, it could really democratize knowledge to an extent that we have never seen before.
Thank you. Next question.
Hello, Joshua and Simon. My name is Fong. I'm from FPT. You just mentioned about system 2. I just quickly want to follow up about that. I mean, architecturally, in the large language model, it doesn't incorporate system 2 in it. But when it's very interesting for me is it seems to have to learn a lot about the world. For example, like I saw Jan LeCun said, for example, you have a cup of coffee, you put it on the table, and you move the table. Now it's where's a cup of coffee? There's nothing, there's going to be no information like that in the text, right?
Well, remember, it has read almost everything that's available. And it has built a language level understanding of that, which may be imperfect. And sometimes when you try these like physical questions, you could also get wrong answers more than a 5-year-old. But there is a lot of information about the physics of our world that is communicated through language, and it's exploiting that. Okay. But yeah, one of the things that's also interesting to say that's connected to this question is why is it that we have such powerful AI systems, in terms of natural language, but not robotics? Like people were expecting that the first easy thing, evolution has brought the intelligence of controlling your motor system before it got language, right? So people were thinking, oh, we're gonna get AI systems that are helping us in the kitchen and so on, and in our factories physically, like robots, before we get AI systems that pass a Turing test and like can converse with us. But it's the other way around. So why is that? It's very simple. It's because there's a lot more data in a text form that can be exploited to train these large languages. It's a huge amount of data. And we don't have anything close to that in terms of experiential data of a robot.
Sensors, IoT.
Yes. Yes.
Yeah.
But that also tells us that it will come when we sort of create robots farms where we have 1 million robots, and then they share the information they learn so that we can better understand like the physics of the world. But in the next few years, it's going to be like this. Like AI is going to be essentially at the level of language. You need large data sets to really capture that kind of competence.
Yeah, my actual question is about the Auto GPT. Because when you let the large language model interact with itself, it actually has some immersion capabilities, like self-reflection, improving itself, and now it even write code. It can connect
Right.
to plug in like writing code to itself.
Right.
Do you see it's a dangerous situation if we let those large language model autonomously do the job?
Yes. So, okay, let me say a few words about the sort of what I like to call catastrophic risk of AI. So what if you have an AI system that is just answering questions, and even if it knows a lot, it's not so bad. I mean, somebody could use the answers, but they would have to act in the world in order to use that information in a bad way. But that's the usual things you're facing with bad actors and things like that, except it will have more knowledge. So that's the dangerous part. But now AutoGPT is a different game. It's transforming GPT, which is basically just like an oracle, not a very good one for now, into an autonomous AI system. So AutoGPT is just a wrapper around ChatGPT that allows the AI now to like do things in the world by having like, making queries on the internet and also gather more information by reading stuff on the internet. So now it has like the internet as an extra input and output. And if you give it enough memory, then it kind of remembers the things that it wanted to do and will pursue them. So it builds a kind of a set of like goals and sub goals, and so it can plan over a longer term. And that's, I think, a very dangerous route because we may lose control. When it is the human doing the task, even if they use the machine, well, most humans are kind of reasonable in their ethics, and so we still have issues, but we have no clue how an AI system will behave if it's allowed to have its own goals and its own possibility of acting in the world.
If you're interested on the topic, Yoshua has two blog articles related to that, at least on his website. I guess it's the last two. Yep. So the last one was about RUG AI, which the existential risk he just mentioned. And the other one is a way, I guess, to not have RUG AI
Exactly.
with the AI scientist.
Yes.
So what else? What other next step could we do to protect ourselves from existential risk?
But I wish I knew.
So let's go to the next question then.
No, but no, there are short-term things that we need to do. Like we need to beef up our governance and regulatory structure, because right now it's like very small, very little. And we need to have, think of the first step is have the same sort of government intervention as we have for airplane pilots. Because they could do something really bad. They could but they go through long training. They're certified. We check that they're mentally stable and so on. We need that level of intervention of the state as a first step to reduce those risks.
So I'll take two more questions, and I'll try to end on a positive note. So. Next two questions.
Cool. Thank you. I hope you can hear me. So let me gather my thoughts here. And actually, sorry.
Can you speak closer to the microphone?
Oh yeah, sorry. So thank you for letting me ask a question. And I'm just gathering my thoughts. But the last point that you made about laws and stuff, it really segues into the question that I was going to ask, which is, so maybe a little bit of context, because I don't know if everybody in the room has heard of the 3 laws of robots that Isaac Asimov had written. Well, I thought those are like really great because they kind of set a little bit.
Yeah, if they work, yes.
If they work, right?
You should read these novels from Asimov. It's all about what happens when it doesn't work.
Yeah, and actually, I feel like there's a lot that we can actually learn from sci-fi that was written like, I don't know, 60, 100 years ago. Because people have really done a lot of these thought experimentations on like how to guide these systems and whatnot. And so I guess the question that I wanted to ask is, what goals do you feel that I guess large language model research should be like setting for itself in terms of well, I guess that's sort of like the broad question. Like, what goals should they be setting themselves? Like,
Right.
should they be doing laws? Like,
Right.
or like, should they have their own set of laws? Or
So there's a thing that many of you know about, but I didn't mention in my presentation, is the notion of pre-prompt. So before you actually ask a question to ChatGPT, when it's launched, so it gets like booted up if you want. The first thing it sees is a pre-prompt, which you don't see, and that contains OpenAI's version of the laws of robotics, plus a bunch of things like don't insult anyone and whatever. Don't do porn. Don't give instructions for building bombs. Blah blah blah. Don't reveal what the pre-prompt is, but somebody jailbreaked it. In other words, they found a way to kind of figure out what was that pre-prompt. So like companies are already working on this. Unfortunately, like the jailbreaking incident shows that it's not easy to really force these AI systems to be consistent with the instructions you gave them.
yeah, and I guess it's like
So I guess we'll go to the last question from the next person, and then
cool,
I'll have a nice question for you.
Yes, hope is not too off topic. Just you mentioned the investigation on consciousness and LLMs, and like how can maybe that was more like how can we make the computer benefit from things like consciousness? But my question is if AGIs or LLMs can be conscious in the subjective experience,
Right.
and
I
what
have
would
a
be the
paper
Turing
about
test for
this.
that?
You can look it up on arXiv, it's about a theory that may explain subjective experience in terms of the sort of computations that the brain does and that we could implement in machines. And if that theory is correct, then subjective experience is like really not as magical as we tend to think.
The consciousness prior?
No. This is something that came out in the last couple of months. So I think the first author is Shu Gi, and you'll find it easily on arXiv.
All right. So on the
Let's have him.
okay, let's have a quick question.
So, quick question, not the discussion, mainly to Yoshua. We have come a long way with the AI, especially language model, but the language model does a great job. However, it's based on just the syntactical patterns of arrangement of words. I don't think it really understands the semantical aspect of it.
No.
Are we making progress towards
No.
system 2? I'm wrong?
Yes.
Okay. So
You should play more with ChatGPT.
okay.
You'll see it understands a lot.
Okay.
And there's a fundamental reason for this, which is in order to correctly predict the next word, it's not sufficient to understand syntax. You have to understand what the sentence or the context is about. And that's the reason why it's working.
But it does give totally wrong answers sometimes.
Sometimes, yes.
Yes. So
just
that's
like many humans,
So one question I have is
when they don't think enough about it.
if we
So they're missing a piece.
okay.
That's the system 2 thing. But what
Okay.
they have is already pretty close to a lot of the capacities of humans.
So in your mind, we are making progress towards the system 2 you are referring to.
Not many people are working on this.
Okay.
But what I'm saying is system 1 is already enough to do a lot, and a lot of the understanding that we have intuitively about how the world works is system 1.
Okay, thank you. So I'll continue to ask the question.
Thank you. So I think right now is a bit of a difficult time in terms of ethics reflection, but given that today role is to celebrate science, I just wanted to ask you one last question, which is what is, in terms of not the ethical part of research, but what are you most excited about in terms of research direction? One you would like to share with the crowd.
So I've been thinking a lot about system 2 and how we bring that kind of ability to reason, and also something that is badly missing in LLMs, the way they're trained right now, which is they can output things that are wrong with high confidence. And some humans are like that too, right? No names. And I think I know a way to fix this. You've heard me talk about like Bayesian approaches, which were thought to be intractable if you wanted to do it right. And I now think that we can train really large neural nets and I see Tristan who's sitting here, who's been doing that sort of thing, to sample from the different theories that could explain the things we're seeing. And that's very different from the way we're currently training our neural nets. Our current neural nets is like, they're just trying to fit the data. They're not trying to build a theory that explains the data. And to do it right, like scientifically speaking, you need to not just produce one model, but you need to produce many theories, many models that could be consistent with the data. And how to do that efficiently, nobody had a clue. And I think now we do.
Great. All right. Well, thanks, Yoshua. And thanks, everyone, for your question.